risk my life, not afraid to die. Type to make you cry, type to put a price all up on your head. Do just what I said. I'm a straight up villain, got no feelings.
Hi guys, this is Atwood here today with a super cool presentation of my ionic compound. So let's start with tabbing the Fortnite creative to explain what my ionic compound called potassium nitrate is. Alright, as you can see, I'm in Fortnite creative to demonstrate my ionic model. Anyway, say hi to Fortnite Miss McBaron. She's my good luck charm for this comp, so let's get this comp started. So potassium nitrate, aka KNO3, is a very unique ionic compound, mainly because there's a covalent bond inside of the ionic bond. You can actually see right here with the NO3 on the model I made myself, it took me like an hour. You can see how the nitrogen and oxygen have like actual bonds. This one has a single bond, that has a single bond, and these are double bonds. But this potassium right here, it's all alone. And obviously, like these bonds, they're a sign of a covalent bond. So I think that's kind of cool. And this is why it's an ionic bond, because this potassium right here is the thing that's being ionically bonded to here. This is what makes it covalent, or no, it's not covalent, sorry, ionic. And so if this weren't here, this would be a covalent bond. But how is this the case? The potassium only has one valence electron, like the normal potassium, not the positively charged one right here. But so normally potassium has one valence electron, but there's like what, 1, 2, 3, 4, there's 4 atoms / elements or ions on here, but there's only one valence. How would that work? How would that bond to here? So that's actually the tricky part. But actually, the tricky part, I'm going to simplify it because I don't want this video to be like 20 minutes long. So if you look over here, this is a polyatomic ion, which is what that thing is over there. So a polyatomic ion is a covalent bonded set of 2 or more atoms that can be considered to behave as a single unit and has a net charge that is not 0. So the example would be NO3 with a negative charge, aka nitrate. And that seems really familiar, because if you look over here, oh look at NO3. There's 1 nitrogen, 3 oxygen, and has a charge of -1 because the 2 negative ions and the 1 positive nitrogen. So now that we know we can treat this nitrate as a single, well, technically a single ion, if you put it in a nutshell, things become much more easier from here. From here, we can prove that they bond, or we can show that they bond with electrostatic attraction. So, what is electrostatic attraction? It's when a negatively charged ion is attracted to a positively charged ion, and vice versa. So basically, like a magnet, you get like the opposite sides of a magnet, and like you like put them together, and then boom, like they stick together. So you have like same size of a magnet, it doesn't go together. So we can use this to show. For example, potassium, that's positively charged, is a cation which has an electrostatic attraction to the nitrate over here. That has a negative charge, obviously from the 2 negatives outnumbering the 1 positive right there. Anyways, that's it for now. I just gotta mention 3 important things about what's it called? Potassium nitrate. Number 1, it's highly unstable, and you have to work carefully with it. 2, it's used for gunpowder. So basically, if this didn't exist, I don't think Fortnite would have existed, because Fortnite has guns, like the gold scar right here. But without gunpowder or anything, I mean, obviously Fortnite would have existed. So it's pretty cool. I'm grateful this existed. And 3, it's used for fertilizer. So next time you're eating a carrot, you gotta remember that you're eating the same thing, or your carrot is grown with the same thing that is used to make 9mm. So anyways, that's it for my covalent compound. Hi guys, Howard here again with my Roblox demonstration on my covalent compound, which is cocaine. So first, I'd like you guys to look at my 3D model of cocaine. See, it's very intricate. It took me a very long time to make. So you can see the hydrogen, the bonds, the electrons, and stuff like that. It took me like 2 hours to make. Anyways, here's the chemical compound of what we call cocaine. You can see it's mostly comprised of carbon and hydrogen. There's also some oxygen and nitrogen there as well. But yeah, I think it's a pretty lengthy formula. If you look at this Lewis model again, you can see that this Lewis model of cocaine is very long and intricate. But don't worry, I'm going to split this into two so it's more digestible for you guys. Starting on the left, you can see this hexagonal pattern that's actually called a benzene ring. So I'll move over here. So a benzene ring is a 6-carbon ring structure that's used for many organic compounds like cocaine. And organic compounds are made mainly from carbon, hydrogen, oxygen, and nitrogen. That's exactly what cocaine's made out of. The really cool thing about this ring is that it's really stable because how the hexagonal structure allows each of the 6 carbons and the hydrogens to have a full valence shell. So for this one has 4 bonds, the carbon can take 4 bonds, and then obviously there's 4 bonds. And then same for hydrogen, obviously hydrogen can only make 1 bond, and so I think that's pretty cool. Moving to the right of the Lewis structure, we can see that we can apply the same principle as with the benzene ring. So I'm going to fly up right here. Let's see. If we look at this carbon, we can do the same. This carbon attaches to this, and the rest creates 4 bonds. Same for that carbon, same for that carbon, and so on with the hydrogen and nitrogen. I think that's really cool because the rest of the structure, they all work together in tandem so that they can all achieve 8 valence electrons. For my VSEPR, I decided to choose this chunk of my compound with the oxygen and the 2 carbons. So I moved that part over here, and we can see that I put this VSEPR shape as a bent, or technically call it angular as well. And I know this because these 2 pairs of electrons represent these 2 pairs of electrons. The oxygen is in the center, so it would be right there, and then the 2 carbons would be in the bottom. And also, this model isn't really realistic because obviously carbon needs 3 other bonds besides this one, and same for that one. But I couldn't find any other ones that were stable, so I just chose this one. I'd also like to show my 3D model I made in class. So here it is on the screen, it should be popping up. And as you can see, it's a bent shape with carbon and oxygen. Honestly, I wouldn't know because I was recording this audio before I made the 3D shape. So I hope that the shape is good. Lastly, I'd like to show 3 things about cocaine. So over here, here's the list. So number 1, it's a very highly addictive drug. 2, it was used for anesthetics, and 3, it was in the original formula for Coca-Cola. So one of the original formulas, one of the first ones, had cocaine in it. Thanks for watching my video. One last surprise I have before I end my presentation is the amazing basketball match between these Roblox characters. You guys might notice some of these Roblox characters from somewhere. And that's right, it's because it's you guys. It's the Roblox avatars of my classmates. See, we have Blake here on the floor, Aiden's Roblox avatar, we have Mason's, we have Reed's, we have Jonathan's, we have Abraham's, we got Ernesto's, and we don't talk about this guy. But yeah, I think that's it for my presentation. Hope you guys enjoyed, and